You build things. You create systems, intricate digital worlds. But let's not be naive. Underneath the surface of elegant algorithms and efficient data structures lies a fundamental struggle. The fight against error, against chaos, against the inevitable decay of any complex system. And that struggle, that relentless pursuit of order, is what makes programming both terrifying and strangely addictive. It's the constant struggle against the beast of imperfection, the endless debugging, the agonizing search for the elusive bug. It's a test of will, of endurance, a Sisyphean task that nonetheless holds a grim, almost hypnotic fascination. It's a battle against the chaos within the code and within ourselves. Take the stack, and I mean really think about it. The stack isn't just a data structure, it's a testament to responsibility. Every element pushed onto that stack is a promise, a commitment that must be honored before you can move on. It's like climbing down into a dark, twisting mine shaft. Every step you take, you delve deeper, and you can't just magically teleport back to the surface. No, you have to retrace your steps with precision and discipline, facing each level as you rise. And if you think that's just a technical decision, you're missing the point. Because here's the thing, when that stack overflows, when you've taken on more than you can handle, that's not just a runtime error. That's a reflection of a pattern we see throughout history, individuals and societies collapsing under the weight of unfulfilled commitments. And what happens then? Total system crash, and that's no joke. Now, the queue. The queue is a profound representation of delayed gratification. First in, first out, that's not just an implementation detail. It's a fundamental truth of nature. The caterpillar doesn't get to skip the chrysalis stage to become a butterfly. The seed doesn't get to skip the winter to bloom in spring. When you try to circumvent the natural order of processing, when you try to pull from the wrong end of the queue, you're defying the very fabric of existence. You're inviting chaos into a system designed for order. And that, my friends, is a dangerous game. Now let me tell you something about the linked list. It's not just nodes pointing to nodes. It's a manifestation of the interconnectedness of existence. Every node must know what comes next. Every element must understand its place in the grand tapestry of being. When you modify that list, when you daringly restructure those connections, you better know exactly what you're doing. Because when you break a connection in that list, when you point a node to the wrong place, you don't just lose one piece of data, you lose everything that follows. It's like a chain of cultural transmission. When you sever a link in the chain of tradition, you don't just lose one element, you lose all the accumulated wisdom that came before. You see this same pattern in Western civilization, by the way. When we lose our connections to the past, when we sever our links to tradition and meaning, that's exactly like corrupting a pointer in your linked list. And what happens then? You lose access to everything that follows. Complete severing of inherited knowledge. Now, let's talk about something really dangerous, reversing a linked list. When you reverse a linked list, you're not just swapping pointers. You're fundamentally inverting an established order of being. You're taking everything that pointed forward and making it point backward. And you better know what you're doing, bucko, because this is exactly the kind of transformation that Carl Jung wrote about. It's like the archetypal hero's journey, but in reverse. You have to traverse the entire chain of meaning, carefully maintaining your grip on 3 points of reference: where you've been, where you are, and where you're going. And if you lose track of any of these, if you lose your previous node, your current node, or your next node, bang, total catastrophe. This is why reversing a linked list is one of the most archetypal coding interviews, by the way. It's not just about technical skill. It's about whether you can handle reorganizing an entire structure of meaning without losing your grip on reality itself. It's about whether you can transform chaos back into order. Now, the tree structures are fundamental. When I say fundamental, I mean they represent something so profound, so deeply rooted in our collective consciousness that it staggers the mind. The binary search tree isn't just about efficient lookup times, for heaven's sake. It's about making proper discriminations. Left or right, smaller or larger. These are judgments. And you know what happens when you don't balance your tree properly? When you let nodes accumulate on one side without proper rotation, you get a degenerate tree. It collapses into essentially a linked list. And if you think that's just a performance issue, you're not thinking deeply enough. That's exactly what happens when a society loses its ability to make proper hierarchical distinctions. And don't even get me started about tree rotations. When you rotate a tree, you're literally reorganizing a hierarchy while maintaining the fundamental order. It's like what happens during political revolutions, except, and this is crucial, except when you rotate a tree properly, you preserve the essential relationships. Unlike what happened in the Soviet Union, where they tried to completely flatten the hierarchy. That's catastrophic. Now, the graph. The graph is perhaps the most terrifying data structure of all. It's a representation of pure potential chaos. Each node can connect to any other node. There's no inherent order, no clear hierarchy. It's like the underlying fabric of reality itself. And when you traverse a graph, you better have a really good algorithm, depth first search, breadth first search, because if you don't, you'll end up in an infinite cycle. And how do you manage that descent into the labyrinth, that exploration of the unknown with the stack, Bucko? The stack becomes your lifeline, your Ariadne's thread in the maze of interconnected nodes. It remembers where you've been, guiding you back to the surface when you've plumbed the depths of the recursion. And you see this same pattern in human psychology. When people get trapped in pathological cycles of behavior, that's exactly like an infinite loop in your graph traversal. That's why we need proper algorithms, proper rules to navigate both code and life. And you better have your visited nodes marked properly, Bucko, or you'll keep repeating the same patterns over and over and over. But there's something even more terrifying about graphs. When you add edge weights, when you start measuring the cost of moving between nodes, that's when you're really playing with fire, because now you're not just mapping connections, you're mapping hierarchies of value. And if you think Dijkstra's algorithm is just about finding the shortest path, that's precisely what makes the postmodernists think they can restructure reality without consequences. Every time you run a pathfinding algorithm, you're literally acting out an ancient pattern of heroic journey through chaos. And that's no joke. Now, debugging. This is where things get really serious. When you're debugging code, you're not just fixing errors, you're confronting the chaos in your own creation. And the first rule is start by setting your ID in perfect order before you try debugging the world. How can you possibly fix a complex distributed system if you can't even organize your own workspace? Treat your code base like you're somebody who wants to maintain it. When you write spaghetti code, when you create these tangled messes of dependencies, you're not just making life harder for yourself. You're manifesting contempt for your future self and for all the other programmers who'll have to deal with your code. And let me tell you something about console.log debugging. That's not even debugging at all. That's like cleaning your room by shoving everything under the bed. You need to stand up straight, shoulders back, and face that debugger like a responsible programmer. Set your breakpoints with precision. Step through your code with attention, because here's what happens, and I've seen this hundreds of times. Programmers start throwing print statements everywhere, randomly changing variables, hoping something works. That's chaos. That's the equivalent of trying to reorganize society without understanding the deep structures that hold everything together. When you find a piece of code that works beautifully, that's clean, that's elegant, stop and appreciate it. Learn from it. Because that's order manifesting itself in the midst of chaos. But the most dangerous bugs, the most terrifying bugs, are the ones that only appear in production. These are like the shadow in Jungian psychology. They represent everything you didn't test, everything you didn't think about, everything you pushed into the unconscious of your system. And when they emerge at 3 a.m. and your entire system is down, that's when you really discover who you are as a programmer. So clean up your code, document your functions, test your edge cases, and for heaven's sake, back up your database. Because if you think you can just deploy to production without confronting these fundamental responsibilities, well, that's the kind of unconscious arrogance that brought down entire civilizations.